right, we are going to go over one example, and then I'm going to encourage you to go ahead and work on these surface area and volume problems. It really does help if you go to this interactive technology piece. If you have not gone there, it will, in my opinion, it'll really make this lesson and your understanding deeper. But here we go with the first problem as an example. For this problem, I would like to do the volume first because for me that's the easier of the two. I've been doing volume for a long time, and I know that this is one of the measurements I need. It is 4 cubes that way. I know that I have another dimension going up and down. That dimension I have 3. And then weirdly enough, for this shape, for this rectangular prism, I have 4 going that way as well. So my dimensions are 4 by 3 by 4. The order does not matter. When I'm multiplying, I have this really cool property called the commutative property, which says that I can rearrange the numbers in any order when I'm multiplying, and I still get the same answer. Especially if I'm doing it correctly. So if I do the math, I have 4 times 3 is 12, and 12 times 4 is 48. So that's 48. I don't have a specific unit of measure labeled, so I'm going to call it 48 units cubed. Why cubed? Because it is 3-dimensional. I have 3 different dimensions that I multiply to get my volume of this rectangular prism, also known as a cuboid in some math circles. Now for the surface area, and that's what we're working on. This same rectangular prism, but this is a newer concept. The surface area is when I take the rectangular prism and I try to find the area of all the faces. The faces you might think of as the sides of the prism. So I'm going to start by looking at the area of the top. In the area of the top, I have going, if this one right here is the same as this one right here, this is 4 by 4. So my area of my top is 4 times 4, and that equals 16. I can't see the bottom, but I know that it's a rectangular prism, and if it is a rectangular prism, then the areas of the top and the bottom, because they're opposite sides, should be the same. So I'm going to go ahead and record that area as well. And then I've got the area of the left. And this over here is the left side. Okay, that's the left side. And I've got 4 going this way. That's 4 by 1, 2, 3. So my measurements that I'm going to use to get the area of the left are 4 times 3, and that is 12. The area of the right that I cannot see is also 4 times 3, which equals 12. And then I have the area of the front. So the area of the front is going to be this area here. And I am looking at that, and I have my measurements of 4 by 3 again, which is kind of weird. Not all the time are we going to have situations where we have so many sides that are the same, but it just happens to have happened in this situation. I wrote those in a different color so you would be aware, or so I'd remind you that, even though we do have the same areas for the sides, we're talking about fronts and backs versus rights and lefts. So our last job is to go ahead and add these up. And I can start at the bottom. 2 plus 2 is 4. 4 plus 2 is 6. 6 plus 2 is 8. 8 plus 6 is 14. 14 plus 6 is 20. So I'm going to write down a 0, carry my 2, 2, 3, 4, 5, 6, 7, 8. So I've got 80, and I can say that my surface area is 80 units squared. Now, the reason that it's squared is because I'm talking about area, even though it's a surface area. So 80 units squared. And I'm going to ask you to work on the rest of them. Do your best. Remember that you need to make sure that you're taking care of all the different sides. Remember that we can remember that the areas of the tops and the bottoms should be the same. These should be the same, and these should be the same. Each time we're going to have pairs of areas that go together, and that will help us, I think, to get our answers more accurately and precise. Good luck.